Our lesson today is going to build on what we learned last week about perfect square numbers and their square roots. So if you recall from last week, a perfect square number is any number that can be written as the product of two identical factors. So for instance, the number 16 can be written as the product of 4 times 4, two identical factors. Okay? If we were asked to find the square root then of 16, what we're being asked to find is, what are those identical factors that multiply to give us 16? Well, then the answer to that would be 4. 4 is the square root of 16. So today, in our lesson, the instructions ask us to rewrite each of these expressions by evaluating the square roots. When you see that word evaluate, it's asking you to find the value of the square root, how much that square root is if it was not written as a square root under the square root sign. Okay? So we're going to first evaluate the square roots, then we're going to evaluate the resulting expression. Okay? So when you look at A, it says the square root of 4. Well, when we look at that, we have to ask ourselves, what are the two identical factors that would multiply together to give me an answer of 4? Hopefully you said, well, that would be 2 times 2. Okay, so the square root of 4 is 2, and the square root of 9, what two identical factors multiply together to give you 9? 3 times 3. So the square root of 9 is 3. Okay, so this expression really says the square root of 4, which is 2, plus the square root of 9, which is 3. When you add that together, 2 plus 3, the value of this expression is 5. 2 plus 3. Let's try the same thing with B. The square root of 5, the square root of 25 is 5, because 5 times 5 is what you would multiply together to give you an answer of 25. So the square root of 25 is 5, minus the square root of 1. Well, what two identical factors multiply together to give you an answer of 1? 1 times 1. So 1. What is 5 minus 1? 4. The value of that expression is 4. Let's have a look at C and D at the bottom of the page. The square root of 16, well, the two identical factors that multiply together to give me an answer of 16. 4 times 4, right. So the square root of 16 is 4 times the square root of 9. Well, 9 is 3 times 3, so the square root of 9 is 3. So my expression actually says 4 times 3, which is 12. With evaluating expressions like this, it is very important that you show your work, that you show your steps. Okay? Because even if you happen to make a mistake when you multiplied the 4 times 3 part and you didn't get an answer of 12, you still could get part marks for showing that you know what the square root of 16 is, 4, and that you know what the square root of 9 is, 3. So always get into the habit of making sure that you're showing every step like I'm showing you here in this lesson today. Okay, the square root of 36, well, ask yourself what two identical factors multiply together to give me an answer of 36. 6 times 6. So the square root of 36 is 6 divided by the square root of 9. Well, 9 I know is 3 times 3. So the square root of 9 is 6 divided into 3 equal groups. How many would be in each group? I'm giving you a minute to figure that out in your head. Hopefully you came up with an answer of 2. There would be 2 in each group. Let's see if we can do the same thing, but this time there are 2 operations involved instead of just 1. We're doing the exact same, just a little bit more complex. Okay, so the square root of 64. What two identical factors do I multiply together to give me an answer of 64? What times what? times 8 fell on the floor. Pick it up. It's 64. Right, so the square root of 64 is 8. Times the square root of 9. Well, I know that 9 is 3 times 3, so the square root of 9 is 3. Minus the square root of 4. What times what multiplies together to give me 4? 2. Okay. Now I have an expression that involves two operations. I have a multiply and I have a subtract. So I need to make sure that I use BEDMAS, the order of operations, to evaluate this expression. Would I multiply first or subtract first? Right, we would have to multiply first. So I have first 8 times 3, which is 24, and then I'm subtracting 2. 24 minus 2, 22. That'll be my final answer. Let's have a look at B. Well, we've already figured out the square root of 64. Square root of 64 is 8, because 8 times 8 is what gives us 64, times, and then I see brackets. So keep the brackets in place. So we're going to figure out what the square root of 9 is. What two identical factors multiply together to give me an answer of 9? 3. 3 times 3. Okay, and what about 4? What two identical factors multiply together to give me an answer of 4? 2 times 2. Now again, I have to remember to use order of operations, BEDMAS. And BEDMAS says that I always do any operation that I find in brackets first. So I have 3 minus 2, which would be 1. So I have 8 times 1. My final answer will be 8 times 1 is 8. Okay. C. Square root of 64 again. Well, I'm going to know this one off by heart pretty soon. Square root of 64 is 8, because 8 times 8 are the two identical factors that multiply together to give me 64. Minus the square root of 9. Well, I'm getting to know that one as well. 3 times the square root of 4. 2. Okay, now I have a subtract and a multiply. I have to make sure that I'm using correct order of operations. And order of operations say I'm going to multiply first before I subtract. Right? So I have to do 3 times 2, which is 6. And then last step I'm going to do the subtraction. 8 minus 6. 8 minus 6 is 2. Okay, and again, the square root of 64 is 8, but this is in brackets, so keep it in brackets. Minus the square root of 9, which is 3, times the square root of 4, 2. Right, okay? Again, BEDMAS says I always do any operations I find in the brackets first. So 8 minus 3 is 5, times 2, which is final answer of 10. Okay, so when you have two operations, when you're asked to evaluate square roots, nothing is different. You just have to remember to apply the order of operations. You do brackets first, then you do any multiplying, well, exponents if there were any, but there aren't in these questions. Then you do any multiplying and dividing in the order you come to them, working left to right. Then lastly, you do any addition and subtraction in the order you come to them, left to right. All right, this question says, evaluate each of these square roots by first evaluating the square inside the root cell, the square root cell. Okay, so here's an example that has been worked for us. What is the square root of 9? Well, if we have the square root of 3 squared, okay, remember that 3 squared, this notation means the square root of 3 times 3. That's what 3 with the little 2 up in the air, superscript, means. That means we're taking the base of 3, we're multiplying it by itself 2 times. Okay? So that's why 3 squared is equal to 3 times 3. That's what's under the square root sign. The square root of 3 times 3 is the square root of 9. And the square root of 9 is, final answer would be 3, right? Because 3 is the identical factors that multiply together to give you an answer of 9. Okay? So let's have a look at 1 squared. The square root of 1 squared. What this is really asking us for is the square root of 1 squared, which is 1 times 1. That's the square root of 1. And the square root of 1, what two identical factors multiply together to give us an answer of 1? Well, 1 times 1, right? Let's have a look at the second one, the square root of 2 squared. Well, that's the same thing as saying the square root of 2 times 2. Well, that's the square root of 4. And the square root of 4 is what two identical factors multiply together to give us 4? Well, 2. Square root of 3 squared. Well, that's the square root of 3 times 3. That's what 3 squared means. Well, that's just the square root of 9. Well, what two identical factors multiply together to give us 9? That's 3. Are you starting to see a pattern here when we're taking the square root of a number squared? Remember the other day we said those are opposite operations. Taking the square root is the opposite of squaring something. In other words, when you use opposite operations, they cancel each other out. They zero each other out. So these cancel each other out, and you're just left with 1. That's what our answer was. Have a look here. The square root sign cancels the squared sign. Your answer is 2. The square root sign cancels the squared operation. Your answer is 3. So let's see if we can do the last two without even needing to show all of the work. If we are taking the square root of a number squared, those two operations are opposite operations. They will cancel each other out. Your answer would be 4. Right. Same thing here. Taking the square root of 5 squared. So the squared and the square root are opposite operations. They're just going to cancel out. You're left with the 5 as your final answer. So just like addition and subtraction are opposite operations and they will cancel each other out and get you back to what you started with, just like multiplication and division are opposite operations and they will get you back to what you started with, so will taking the square root of a number and squaring a number. They will get you back to the original number. Let's have a look and find all of the perfect squares on a multiplication table. Okay, well, the first perfect square would be 1 times 1. That is not on this table. So we'll go to the next one, which would be 2 times 2. Well, that's 4. And 3 times 3, well, that's 9. And 4 times 4 is 16. And 5 times 5 is 25. And 6 times 6 is 36. Are you seeing a pattern here? 7 times 7 is 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. Okay, one last set of questions to evaluate. We're going to have a look at these expressions and see if they are equal. They have the exact same numbers and the exact same signs, but the difference is the bracket. Okay, so we have the square root of 9 plus the square root of 16. And we want to see if that gives us the same answer as when we bracket that whole amount, and we do it as the square root of 9 plus 16. Okay? So let's evaluate this. The square root of 9. What two identical factors multiply together to give you an answer of 9? That's 3, right. Plus the square root of 16. What two identical factors multiply together to give you an answer of 16? 4, right. Okay? So this expression is 3 plus 4, which is 7. Let's see what happens if we take the square root of 9 plus 16, okay, as one amount. Well, 9 plus 16 is, hopefully you came up with 25. So this is really asking me for the square root of whatever 9 plus 16 is, and that's 25. What's the square root of 25? Well, what two identical factors multiply together to give me an answer of 25? 5. Are my two answers the same? No, they're not. It makes a difference when we use order of operations. Okay, let's have a look at the second one. The square root of 4, which is what two identical factors multiply together to give me an answer of 4. Hopefully you came up with 2, right? 2 times the square root of 25. What two identical factors multiply together to give me 25? 5 times 5. So 2 times 5 is what this expression is saying, which is 10. Okay, let's see if the square root of whatever 4 times 25 is. No? 4 times 25. 4 25s. Think of money. Think of 4 quarters. How many cents do you have if you have 4 quarters? 100. Okay, that's actually the square root of 100, which is what two identical factors multiply together to give me an answer of 100. What times what? 10 times 10 is 100, right? So the square root of 100 is 10. Interesting. In that case, my two answers were the same. Okay, let's try the last one. The square root of 100. Well, we just did that a minute ago right here. The square root of 100 was 10, because 10 times 10 is 100. Divided by the square root of 4. Well, I know 2 times 2 is 4, so that's 2. 10 divided by 2 gives me an answer of, that means 10 divided in half into 2 equal groups, 5 in each group. Okay, let's try this. This is the square root of 100 divided by 4. Well, if I have 100 cents again, and I'm dividing that into 4 equal groups, how many are in each group? Well, that's back to my quarters again, isn't it? I got 4 25s. So that's the square root of 25. 100 divided into 4 equal groups. 25 in each group. Square root of 25, what two identical factors multiply together to give me an answer of 25? 1 times 4. Oh, look at that. My answers are the same again. When you finish this video, we will go over some questions tomorrow in class that are very similar to this, and then there will be an assignment for you to work on as well.